Hello everyone, my name's Tim Bunning, Chief Technology Officer here at the Air Force Research Lab, which is headquartered at Wright-Patterson Air Force Base here in Dayton, Ohio. Pleasure to be here, pleasure to help support the WOW program, the Wizards of Wright, and the Educational Outreach Office here as we develop a lesson around how do you measure the volume of an irregularly shaped object. We're going to do that through a method called water displacement, and it's pretty simple. When you get into a tub full of water, the level of the water in the tub goes up, and that's because your body mass is displacing the water around it, making the level rise. So we're going to do something very similar. We're going to take this irregularly shaped object, a rock, and we're going to use water to be able to measure what the volume of the rock is and ultimately what the density is. As you know, volume is the amount of space an object takes up. So think of a balloon, think of the amount of air that balloon holds. That is the volume. The volume of a basketball is a lot larger than the volume of a golf ball, even though both are spherical in shape. So this method was first discovered by a man named Archimedes. Everyone calls me old, but Archimedes is very, very old. He was a famous mathematician and inventor back in ancient Greece. He is best known for the discovery of the relationship between the surface and the volume of a sphere. But he also found a method for measuring the volume of an irregularly shaped object like this rock. So I have a scale here, which the first thing I will do is I'm going to measure the mass of the rock. It measures 14 grams. Second thing I'm going to do is we're going to measure the volume of the water. This is what's called a graduated cylinder. It's what in a chemistry lab you use to measure out reagents and solvents, etc. Think of it as a spoon when you cook. You know, you have different size spoons to put your ingredients in. This is how we measure the ingredients in a chemistry lab for liquids. So it measures 52 milliliters of water. So now what we're going to do is we're going to put the rock into the water, and we're going to see how high, what additional level increased. And we are now at 58 milliliters. Now it's important to know milliliter is a measure of volume, cubic centimeter is a equivalent measure of volume, and they're equal. So 1 milliliter is equal to 1 cubic centimeter. And so in science, it's very important to pay attention to your units to be sure you aren't making a mistake. The degree that I have in chemical engineering, you spend a lot of time converting X to Y to Z to A to B, and the thing you have to make sure you keep track of is all of the units, so that you have the right units on the back end. So knowing that 1 milliliter is equal to 1 cubic centimeter, that's very important that you understand the equivalency of the units. We have the volume and we have the mass. We can calculate what that density is. So if we take 14 grams and we divide it by the 6 milliliters, we get 2.33 grams per unit centimeter. So that's the density of the rock. So you can now use this method to calculate the volume of your objects and therefore the densities. Compare the answer to the ones you get using other methods, and then have a discussion with your teacher about the accuracy and the precision of each method. I hope you've learned more about measuring density today, and I thank you for joining me.